Okay, so now that we've taken the notes on section 2.1, we want to look at some examples of how we'll use the notes that we just took. So example 1 you can see says, describe the transformations of the graphs for each equation compared to the parent function f of x equals x squared. So anytime we talk about transformations, we are comparing it to that parent function, which is important to know. Okay, so if I follow the rules we just talked about, in this g of x, number 1, I see that it's negative 1/2 times x plus 2 squared. I first focus on translations, which is anything that's being added or subtracted. And in this case, I see that there's an x plus 2 in parentheses. That means that it affects the graph horizontally, or left and right, and it's the opposite of what it meant. So I see the plus 2 actually means h is negative 2. So it's going to go left 2. That's what that x plus 2 does. Now, next, I'm going to look at this multiplication. I have negative 1/2. That's that a value in front of the parentheses. That actually tells me two things. First, I think about the negative. And I remember that if that a value is negative, it actually makes the graph upside down. It's going to be upside down like this. And then the 1/2, because it's outside of parentheses, that means it affects the graph vertically. And anytime it's vertically, it's as you would think. When we're doing multiplication, that's when we have stretches and compressions. So since 1/2 is between 0 and 1, it is actually a vertical compression by 1/2. Okay, so those are the three things to describe it. On the next slide, I'll show you a summary of that and also a picture of the graph. Number 2 has a little bit more going on. Okay, I'm going to start the same way. I'm going to look for adding and subtracting because I'm going to talk about translations first. I start again by looking inside the parentheses. I see x minus 1. It affects the graph left and right. It's minus 1, the opposite of what I think, so it goes right 1. This time, we have this minus 3 on the end. It's outside of the grouping symbol, so it's not with the x, which means it affects the y's values or it affects it vertically. Minus 3, it's vertical, so it does what I think it would do, so it goes down 3. So this parabola is going to shift 1 right and down 3. Then I can't forget to look at this a value. Again, the a value, in this case, is positive, so it's not going to change, which means it's going to open up. It'll look like this. And then finally, it's a 2, so it is going to be a vertical stretch this time because it's greater than 1. Okay? All right. On this slide, you can see those examples. This is everything we just talked about, except it also shows the picture. So again, what happens if we take the original graph, which is x squared? I always like to take the vertex first, and we said it's going to go to the left. So 1, 2 to the left, that's where the vertex is. We said it's going to be upside down, and that it was going to be a vertical compression, which makes it wider. You can see that the red one's a little wider than the blue. In order to figure out exactly where those points go, sometimes I like to take a T chart, and I can take 2 points right next to the vertex. So if I can plug in x is negative 1 and x is 0, I plug that into the original equation, and that allows me to figure out exactly where that point is. So if I plug in negative 1 plus 2 is 1, 1 squared is 1, 1 times negative 1/2 is negative 1/2. So this point is actually at negative 1, negative 1/2, and then you can just reflect it across that line of symmetry. Okay, if I plug in 0, 0 plus 2 is 2, 2 squared is 4, 4 times negative 1/2 is negative 2. That's 0, negative 2, reflect it across. Okay, fine. So in just a minute, we'll do some examples where you're actually going to graph it as well. Okay, and then you can see the same thing here. We took the vertex at 0, 0. We went 1 right, 3 down like we said. And again, if you plugged in those next points, you'll find what. Right, so I want you to take a second, pause the video, and at a minimum, describe the transformations of these two, and then turn the video back on and see how you did. And then also, if you want to try graphing it, do, otherwise follow. So you should have this, and you should have had left, and then it should be down. So we can graph this one. Again, the parent function like this. This is x squared. So here I would go take the vertex and I would go left 2 here, and then it opens down. Okay? If I want to figure out the exact points that it opens, again, I would make my xy table. I would put in like -1 and 0. And again, -1 squared is 1 squared, but -1, 1. Flip that over. And then when I plug in 0, 2, 3, 4, so I get 4. There. So you can see that it actually has the same width. It's just going to be upside down. Okay, last but not least, if I look at this one, you should have had right 1 up 2. And again, if I take the parent graph, I go right 1 up 2. If I want to, I could plug in 2 and 3, for example. 2, 3, 2 minus 1 is 1, squared is 1, so that'd be at 2, 3, which means 0, 3. If I plug in 3, 2 squared is 4, so that gets 6. 3 minus 1 is 2, 6. Okay, so we'll be up here. Oops, sorry. And again, in this case, it has the same width, it's just upward. Okay, so what are the key features of the quadratic function 2 times x minus 3 squared plus 4? I would first say that it goes right 3. I would say that it goes up 4 because of this. And then finally, it opens up because the 2 is positive, and it is a vertical stretch because that is bigger than 1. When I go to graph it, again, I would take the point that was at 0, 0, right 1, 2, 3, up 4, 1, 2, 3, 4. If I want exact points, then I could plug in 4 and 5. 4 minus 1 is 1, squared is 1, times 2 is 2, plus 4 is 6. I have a point at 4, 6. And then I reflect it, also here. When I plug in 5, I get 5 minus 2 is 2, 2 squared is 4, 4 times 2 is 8, 8 plus 4 is 12. So that's 7, 8, 9, 10, 11, way up here. So you can see that it's here, and it's up there. And now we can use this to find the vertex. Remember, this is my vertex. We said we went over 3 up 4, so it is at the point 4. As a reminder, you can get that right out of your equation. Axis of symmetry is the vertical line that cuts the parabola in half. The vertical line is x equals, so whatever that value is of the vertex, x equals 3. The minimum value is the lowest or highest point. That's going to be the y value of the vertex. So that's at 4 in this case. Domain parabolas go left and right forever. So it's negative infinity to infinity. And range, the lowest y value is right here, which is at 4. It is a point on the graph, so I move it, and then it goes up further. It's always a parenthesis next to it. All right, last but not least, I want you to try this example, doing what we just did. Identify the vertex, axis of symmetry, minimum or maximum, domain, range. Pause the video and then come back and check to see how you did. Okay, so here's what you should have. You should have had that it left 4, down 5, these, and that it opens down because of the negative. I sketched my graph here where I went left 4, down 5, found the 2 extra points, and the graph looks like that. The vertex then is at -4, 5. Axis of symmetry then is at x equals -4. The minimum or maximum, in this case, it would actually be a maximum because it's the highest point on the graph at -5. Domain is still -infinity to infinity. And now the range, be careful on this one. Remember, you always have to go from smallest to biggest. These arrows go down forever. So it does go down to -infinity, and then it stops at -5. Okay, so that's the end of today. So you can go ahead and start working on your homework and make sure you know what questions you have for next time we touch base. Thanks.